Falsifiability or refutability of a statement, hypothesis, or theory is the inherent possibility that it can be proven false. A statement is called falsifiable if it is possible to conceive of an observation or an argument which negates the statement in question. In this sense, falsify is synonymous with nullify, meaning to invalidate or show to be false. For example, by the problem of induction, no number of confirming observations can verify a universal generalization, such as all swans are white. Yet it is logically possible to falsify it by observing a single black swan. Thus, the term falsifiability is sometimes synonymous to testability. Some statements, such as "it will be raining here in 1 million years," are falsifiable in principle, but not in practice. The concern with falsifiability gained attention by way of philosopher of science Karl Popper's scientific epistemology, falsificationism. Popper stresses the problem of demarcation, distinguishing the scientific from the unscientific, and makes falsifiability the demarcation criterion, such that what is unfalsifiable is classified as unscientific, and the practice of declaring an unfalsifiable theory to be scientifically true is pseudoscience. Overview. The classical view of the philosophy of science is that it is the goal of science to prove hypotheses like, all swans are white, or to induce them from observational data. Popper argued that this would require the inference of a general rule from a number of individual cases, which is inadmissible in deductive logic. However, if one finds one single swan that is not white, deductive logic admits the conclusion that the statement that all swans are white is false. Falsificationism thus strives for questioning, for falsification, of hypotheses instead of proving them. For a statement to be questioned using observation, it needs to be at least theoretically possible that it can come in conflict with observation. A key observation of falsificationism is thus that a criterion of demarcation is needed to distinguish those statements that can come in conflict with observation and those that cannot. Popper chose falsifiability as the name of this criterion. My proposal is based upon an asymmetry between verifiability and falsifiability, an asymmetry which results from the logical form of universal statements. For these are never derivable from singular statements, but can be contradicted by singular statements. Karl Popper, The Logic of Scientific Discovery. 19. Popper stressed that unfalsifiable statements are important in science. Contrary to intuition, unfalsifiable statements can be embedded in, and deductively entailed by, falsifiable theories. For example, while all men are mortal is unfalsifiable, it is a logical consequence of the falsifiable theory that every man dies before he reaches the age of 150 years. Similarly, the ancient metaphysical and unfalsifiable idea of the existence of atoms has led to corresponding falsifiable modern theories. Popper invented the notion of metaphysical research programs to name such unfalsifiable ideas, in contrast to positivism, which held that statements are meaningless if they cannot be verified or falsified. Popper claimed that falsifiability is merely a special case of the more general notion of criticizability, even though he admitted that empirical refutation is one of the most effective methods by which theories can be criticized. Criticizability, in contrast to falsifiability, and thus rationality, may be comprehensive, though this claim is controversial even among proponents of Popper's philosophy and critical rationalism. Naive falsification. Two types of statements, observational and categorical, in work beginning in the 1930s. Popper gave falsifiability a renewed emphasis as a criterion of empirical statements in science. Popper noticed that two types of statements are of particular value to scientists. The first are statements of observations, such as, "there is a white swan." Logicians call these statements singular existential statements, since they assert the existence of some particular thing. They are equivalent to a predicate calculus statement of the form, there exists an X such that X is a swan, and X is white. The second are statements that categorize all instances of something, such as, all swans are white. Logicians call these statements universal. They are usually parsed in the form, for all X, if X is a swan, then X is white. Scientific laws are commonly supposed to be of this type. One difficult question in the methodology of science is, how does one move from observations to laws? How can one validly infer a universal statement from any number of existential statements? Inductivist methodology supposed that one can somehow move from a series of singular existential statements to a universal statement. That is, that one can move from, this is a white swan, that is a white swan, and so on, to a universal statement such as, all swans are white. This method is clearly deductively invalid, since it is always possible that there may be a non-white swan that has eluded observation. Inductive categorical inference. Popper held that science could not be grounded on such an inferential basis. He proposed falsification as a solution to the problem of induction. Popper noticed that although a singular existential statement such as, there is a white swan, cannot be used to affirm a universal statement, it can be used to show that one is false. The singular existential observation of a black swan serves to show that the universal statement, all swans are white, is false. In logic this is called modus tollens. There is a black swan, implies, there is a non-white swan, which, in turn, implies, there is something that is a swan and that is not white. Hence, all swans are white, is false, because that is the same as, there is nothing that is a swan and that is not white. One notices a white swan. From this one can conclude, at least one swan is white. From this, one may wish to conjecture, all swans are white. It is impractical to observe all the swans in the world to verify that they are all white. Even so, the statement all swans are white is testable by being falsifiable. For, if in testing many swans, the researcher finds a single black swan, then the statement all swans are white would be falsified by the counterexample of the single black swan. Deductive falsification. Deductive falsification is different from an absence of verification. The falsification of statements occurs through modus tollens, via some observation. Suppose some universal statement U forbids some observation O. Observation O, however, is made. So by modus tollens, although the logic of naive falsification is valid, it is rather limited. Nearly any statement can be made to fit the data, so long as one makes the requisite compensatory adjustments. Popper drew attention to these limitations in The Logic of Scientific Discovery in response to criticism from Pierre Duhem. W.V. Quine expounded this argument in detail, calling it confirmation holism. To logically falsify a universal, one must find a true falsifying singular statement. But Popper pointed out that it is always possible to change the universal statement or the existential statement so that falsification does not occur. On hearing that a black swan has been observed in Australia, one might introduce the ad hoc hypothesis, all swans are white except those found in Australia, or one might adopt another, more cynical view about some observers. Australian birdwatchers are incompetent. Thus, naive falsification ought to, but does not, supply a way of handling competing hypotheses for many subject controversies. People arguing that there is no support for such an observation may argue that there is nothing to see, that all is normal, or that the differences or appearances are too small to be statistically significant. On the other side are those who concede that an observation has occurred and that a universal statement has been falsified as a consequence. Therefore, naive falsification does not enable scientists, who rely on objective criteria, to present a definitive falsification of universal statements. Falsificationism. Naive falsificationism is an unsuccessful attempt to prescribe a rationally unavoidable method for science. Sophisticated methodological falsification, on the other hand, is a prescription of a way in which scientists ought to behave as a matter of choice. The object of this is to arrive at an incremental process whereby theories become less bad. Naive falsification considers scientific statements individually. Scientific theories are formed from groups of these sorts of statements, and it is these groups that must be accepted or rejected by scientists. Scientific theories can always be defended by the addition of ad hoc hypotheses. As Popper put it, a decision is required on the part of the scientist to accept or reject the statements that go to make up a theory or that might falsify it. At some point, the weight of the ad hoc hypotheses and disregarded falsifying observations will become so great that it becomes unreasonable to support the base theory any longer, and a decision will be made to reject it. In place of naive falsification, Popper envisioned science as progressing by the successive rejection of falsified theories, rather than falsified statements. Falsified theories are to be replaced by theories that can account for the phenomena that falsified the prior theory, that is, with greater explanatory power. For example, Aristotelian mechanics explained observations of everyday situations, but were falsified by Galileo's experiments, and were replaced by Newtonian mechanics, which accounted for the phenomena noted by Galileo. Newtonian mechanics included the observed motion of the planets and the mechanics of gases. The Jungian wave theory of light replaced Newton's particles of light, but in turn was falsified by the Michelson-Morley experiment, and was superseded by Maxwell's electrodynamics and Einstein's special relativity, which did account for the newly observed phenomena. Furthermore, Newtonian mechanics applied to the atomic scale was replaced with quantum mechanics, when the old theory could not provide an answer to the ultraviolet catastrophe, the Gibbs paradox, or how electron orbits could exist without the particles radiating away their energy and spiraling towards the center. Thus the new theory had to posit the existence of unintuitive concepts such as energy levels, quanta and Heisenberg's uncertainty principle. At each stage, experimental observation made a theory untenable and a new theory was found that had greater explanatory power, and as a result, provided greater opportunity for its own falsification. The Criterion of Demarcation. Popper uses falsification as a criterion of demarcation to draw a sharp line between those theories that are scientific and those that are unscientific. It is useful to know if a statement or theory is falsifiable, if for no other reason than that it provides us with an understanding of the ways in which one might assess the theory. One might at the least be saved from attempting to falsify an unfalsifiable theory, or come to see an unfalsifiable theory as unsupportable. Popper claimed that, if a theory is falsifiable, then it is scientific. The Popperian criterion excludes from the domain of science not unfalsifiable statements but only whole theories that contain no falsifiable statements. Thus it leaves us with the Duhemian problem of what constitutes a whole theory, as well as the problem of what makes a statement meaningful. Popper's own falsificationism, thus, is not only an alternative to verificationism, it is also an acknowledgement of the conceptual distinction that previous theories had ignored. Verificationism. In the philosophy of science, verificationism holds that a statement must, in principle, be empirically verifiable in order that it be both meaningful and scientific. This was an essential feature of the logical positivism of the so-called Vienna Circle that included such philosophers as Moritz Schlick, Rudolf Carnap, Otto Neurath, the Berlin philosopher Hans Reichenbach, and the logical empiricism of A.J. Ayer. Popper noticed that the philosophers of the Vienna Circle had mixed two different problems, that of meaning and that of demarcation, and had proposed in verificationism a single solution to both. In opposition to this view, Popper emphasized that there are meaningful theories that are not scientific, and that, accordingly, a criterion of meaningfulness does not coincide with a criterion of demarcation. Thus, Popper urged that verifiability be replaced with falsifiability as the criterion of demarcation. On the other hand, he strictly opposed the view that non-falsifiable statements are meaningless or otherwise inherently bad, and noted that falsificationism does not imply it. Using courts of law, Judge William Overton used falsifiability in the McLean v. Arkansas ruling in 1982 as one of the criteria to determine that creation science was not scientific and should not be taught in Arkansas public schools as such. The argument was presented by philosopher Michael Ruse, who defined the characteristics which constitute science as explanatory, testable, and tentative, the latter of the three being another term for falsifiability. In his conclusion related to this criterion, Judge Overton stated that, while anybody is free to approach a scientific inquiry in any fashion they choose, they cannot properly describe the methodology as scientific. If they start with the conclusion and refuse to change it regardless of the evidence developed during the course of the investigation. United States law also enshrined falsifiability as part of the Daubert standard set by the United States Supreme Court for whether scientific evidence is admissible in a jury trial.